right, so we have our base sine and cosine function that we've talked about, but you know it's not going to stay that easy, right? We can transform our sine and cosine functions just like we can any function. We talked about this last semester with polynomials and with exponentials, right? So here we can do all the same things. We can have vertical stretches. We can have vertical shifts. We can have horizontal shifts. We can have horizontal stretches or compressions, right? All of those things can happen with sine or cosine. So we're going to talk about all of these variables individually, and then we'll put them all together at the end. All right, so first let's talk about the period of a sinusoidal function. So sine and cosine, as you can notice from what we talked about before, they have many similarities, right? So we're going to kind of talk about them together as we're just going to call them sinusoidal functions. So a base sine function has period 2 pi, right? But we could make it shorter, like this red one. Or we could make it longer. So this looks like this one would have period, like from 0 to 2 pi is half of a period. So it looks like this whole period would be 4 pi for the green graph, right? So here's what this would look like. The green one that's being stretched has the equation sine of x over 2. And this one has sine of 2x. Okay. So here's how you figure out what the period is. Here's your b. It's the coefficient of x. You divide 2 pi by that b value. Okay. So in this case, our b value would be 2. So 2 pi divided by b would be pi, which sure enough, then we see, okay, yep, that red function has period pi. For this one, our b value is 1/2, right? So 2 pi divided by 1/2 would be 4 pi. Yep, looks like if we completed this whole cycle, that would have period 4 pi. Okay, so this is an important relationship. 2 pi divided by b, where b is that coefficient of x. Okay, that tells you what your period is. So determine the period of this function. Sine of pi 6 times x. If you pause it, see if you can do it. All right, so our period is 2 pi divided by b. So in this case, our b is pi 6. So 2 pi divided by pi 6, we get 12. So this function would have period 12. So this is a horizontal stretch. All right, amplitude. So red is just sine x, right? It's going from -1 to 1. It's kind of a cool, like 70s looking like design, right? With all the colors. All right, our blue value is 2 times sine x. Our green value is 3 times sine x. And our orange value is 4 times sine x. So notice they all have the same period. They still all have a period of 2 pi. It's just their amplitude that's changing, right? How high and low they go. And this is pretty straightforward, right? Like the orange one, 4 sine x, it has amplitude 4. Goes up 4 and down 4. So notice the whole thing is 8 from top to bottom, right? But it goes 4 up and down from what we call the midline, right? The midline of the sine function is just 0. And it goes 4 up and 4 down from that midline. So you could say it's 1/2 times the max minus the min. That seems like, I don't know, to me more confusing. All right, so let's say, what's the amplitude of this function? Is the function stretched or compressed vertically? All right, so we have this slightly complicating factor. We have a minus sign out here. What does that do? That's just a vertical reflection. If you remember from last year, right, transformations of functions, that's just going to be a vertical reflection. It doesn't change the amplitude. The amplitude is still just 4. Okay, so that is a vertical stretch. Yep, amplitude is 4, and it's a vertical stretch. And there would be a graph, right? So here we can see what this minus sign does, right? We go down 4 first and then up 4. Normally we go up and then down, right? So the amplitude is 4, but this minus sign reflects it vertically. So it looks like that, right? And our period hasn't changed. Our period is still 2 pi. All right, vertical shifts. So vertical shift, we have a plus d here at the end. It shifts the midline, right? It just makes the whole graph go up or down. So this would be our blue. Here's just sine x. Here's sine x plus 2, right? So the whole midline shifts up by 2, and then the amplitude doesn't change, right? So from there, we go up 1 and down 1. So up to 3 and down to 1, right? And our midline would be 2. Determine the direction of magnitude of the vertical shift of this function. Well, it's just cosine of x, our base function, shifted down by 3, right? So it's going to go from -4 to -2, right? It's going to oscillate that way, 3 units downward. Okay, horizontal shifts of the sine function. So here's blue function is our base sine. Red function is just a shift pi-fourths to the right. Remember, this horizontal shifts are the ones that are slightly counterintuitive. It's x minus whatever the shift is. So minus pi-fourths, that's to the right. X minus pi is a shift pi to the right. Right? If these were plus, then it'd be to the left. So maybe just notice something real quick. Look at this. The blue and the green, looks like those are also vertical reflections of each other, right? Some theme with sines and cosine graphs is that there's many different ways that you could represent the same thing. Sometimes you could represent them as a sine graph or a cosine graph or a reflection or a horizontal shift, right? All of those things are equally correct ways to represent the same function. So one way we could represent this green graph is as a phase shift, a horizontal shift, pi units to the right. Another way we could is just as minus sine x, right, with a minus sign out front. Okay, so determine the direction and magnitude of the phase shift for this graph, sine of x plus pi 6 minus 2. So first of all, this minus 2 is a vertical shift down 2, doesn't affect the phase shift at all, right? And our phase shift is pi 6, and that's going to be to the left. Oops, I did that kind of fast. Whoops. Okay, here we go. All right, so one thing that can get a little bit tricky is if we have a B and a C term. Okay, so if we have our period changes and we have a horizontal shift. Okay, here is the easiest way to do this. Factor your B out of whatever your coefficient of x is out of both terms. Okay, whether it's sine or cosine. This now this is your B value to figure out your period, and this is what your phase shift is going to be, your horizontal shift. Okay, if you just say it's C, that's wrong. Okay, you have to factor this B value out. So you factor this out first and then look at this, and this is going to be your horizontal shift. Okay. So this just kind of tells you, okay, if you have this, here's your amplitude. Your period is 2 pi divided by B. Factor it out of both. Your phase shift is going to be this thing that's left, C divided by B. And this is going to be a vertical shift. Okay, so let's put it all together. Y equals 3 sine of 2x plus 1. All right, first thing, amplitude, 3. Amplitude's always easy. Our B value, we don't have a C value. So our B value is 2. So our period is 2 pi divided by 2, which is just pi. The phase shift is nothing. There's no C value. And the midline is, we're shifting the midline up by 1. So our graph is going to look like this. Okay. Our period is pi. Our midline is shifted up by 1. Our amplitude is 3. So we go up to 4 and down to -2. Right? And what else? That's all. There's no horizontal shift. All right, here we have a graph, and we want to determine a formula for the cosine function. All right. Well, let's just make some observations. It looks like the period is 2 pi. Amplitude is 1/2. We could do this a few ways, right? We could do this as a horizontal shift by pi in either direction, or we could do this as a vertical reflection, right? So either of these could work. They asked us to find cosine. If we wanted to find sine, it could look like this, right? 1/2 sine x minus pi halves. We could shift it. We could see this, if we wanted to do this in terms of sine, shifting it to the right by pi halves, right? And then up by 0.5. But they asked us to do cosine. So this is one way we could do it. We could say that if this is a reflection of the cosine curve, amplitude is 1/2, and it's shifted up by 1/2. All right, let's do this one. Determine an equation for the sinusoidal function. Okay, how can we do this? Well, let's see. It looks like their period starts at 1 and ends at 7, right? So it looks like it has period 6. And let's see, the whole thing goes from -5 to 1. Well, maybe I'll show you some things. D, our vertical shift, our midline, looks like it's down here at -2, right? Because we go 3 units down and 3 units up from -2. All right, so our vertical shift is down by 2. Our amplitude is 3, right? We go 3 units up and down from that point. Our period is 6, right? So this is the first time we've done it this direction. We want to find what our B value is. So B is 2 pi divided by 6. So our B value is pi thirds. All right, so we could do it either way. We could do this as a cosine shift or as a sine shift. If we do it as a cosine shift, it's going to be to the right by 1, right? So our C value would be 1, and if we multiplied it out, this would become pi thirds. If we do, I guess I don't have it on here. What if we did a sine shift? If we did a sine shift, it looks like it would be, well, kind of harder to tell, honestly, since this starts and ends at 1 and 7. Yeah, let's do it as a cosine shift.